Vibes here, and today we'll be continuing our discussion about the dot product, and I'll be talking about some stuff you can calculate with dot product. So as with the previous video, the definition of a dot product is that between two vectors, right, the geometrical definition is that is the length of them times the cosine of the angle between them, and numerically, right, if you have a, b, c dot d, e, f like that. So A and D is the x coordinates, B and E is the y coordinates, and C and F is the z coordinates. Then it's going to be defined as AD plus BE plus CF. So the left hand side is the geometrical picture, and the right hand side is the arithmetic picture, the numerical picture. Okay, so once again, to understand vectors well and to be able to do questions with them, you're going to need to understand both pictures very thoroughly. Yeah. So from the left, you can see that we can calculate if we're given two vectors A and B, right, in that we're given their x, y, and z coordinates, we're given numbers, then we can actually compute the angle between these two vectors by taking one vector dot the other vector divided by their lengths. So what I mean is that if let's say A is equals to 2, 3, 1, and let's say B is equal to 1, 2, 3, we can compute their lengths first. Right? First of all, we can compute their lengths. So the lengths is going to be this. I talked about it in the previous video. It's going to be by Pythagoras theorem, right? And the length of B is also going to be square root of 14. Then we can compute their dot product by taking 2, 3, 1 dot 1, 2, 3 equals to 2 plus 6 plus 3 equals to 11, and we can compute so by plugging it into this formula, right, according to that formula, the cosine of the angle between them is going to be 11 over 2 square root 4, no, not, it's going to be 11 over 14, and hence the angle between them is just going to be the inverse cosine of that, and you can plug this in a calculator, you get some value, and from this value you can deduce that the two vectors are pointing in that the angle between the two vectors is acute because this is a positive value. So you can see that they're kind of pointing in the similar direction, and if we head over to our diagram over here, then we can see that the vectors OA and the vectors OB, right? So OA is this vector and OB is this vector. The vectors OA and OB, they are pointing in similar directions. So yeah. So you move around in 3D space, you can see that OA and OB are pointing in similar directions. The angle between them is acute. Okay? So that's for vectors. Yeah, okay, and another thing that is useful to calculate using the dot product is the length of projection. So let's say we have two vectors A and B. So A and B. Then let's say I want to calculate the length of the projection from A onto B. Okay, so what it means is that at the tip of A, I drop a line that goes down, and this line is perpendicular to the direction of B. And let's say I want to calculate the length of the projection. So the length of the projection is this blue part. So this is sometimes said as A, length of projection of A onto line B. Sometimes you say the line, sometimes you don't say the line. Yeah. So what's the length of projection? The length of projection is going to be equals to the magnitude of A cosine theta, where theta is this angle. This is for the acute case, right? So let's talk about acute case first, and this is actually just equals to A dot B divided by B, the length of B, by the definition of dot product from above. Okay, and likewise, the length of projection of B onto A is going to be um, B cosine theta equals to A dot B over A. Yeah, so you can go vice versa. You can project them onto each other. So that's for the acute case. But for our obtuse case, we need to be a little bit more careful, because the length, if we just calculate the if theta is obtuse, then cosine of theta is going to be negative. So we just need to take the magnitude, the absolute. Sorry, this is the absolute of both, of the of the quantity here. So it will be the absolute of that. So for the general case, right, in general, the length of projection of a vector onto another vector or to the line, right, we'll talk about lines in another video, is the absolute of the length of the vector times the cosine of the angle, which is by the dot product formula, right, from above, by the dot product formula here. We rearrange it to obtain the A dot B divided by length of B. So yeah, so that's another utility of using the dot product. Okay, so yeah, I will yeah, so that's all for this video. In the next video we'll talk about the cross product.